Hey all, let's solve this Leetcode hard problem which says distinct subsequences. I haven't solved it before, so let's see how we can come up with the right approach for this. Let me reset the stopwatch and start again. Yeah, so let me go through the problem statement and constraints once. So we are given two strings s and t. Return the number of distinct subsequences of s which is equals to t. Test cases are generated so that answer fits on 32 bit signed integers. Okay, and length of s and t can be up to 1000. Okay, so we are given two strings s and t, so we need to check how many distinct subsequences of s is equals to t. So in simple terms, if we pick few characters from s in an ordered way, they must be equals to t. Got it? And what is the another thing they have given? Test cases are generated so that answer fits in 32 bit signed integer. So the final answer, the number of subsequences, will fit the 32 bit integer. We don't need to return long. That's what they're saying. And s and t can be up to 1000, and they are of length at least 1. So now how we can solve this? The brute force approach that might be coming to your mind is like, hey, we generate all subsequences of s of length t, and we just check all subsequences whether they are equals to t. If they are equals to t, we increment the count. So what will be the complexity of this? To generate all the subsequence, it is exponential complexity 2 power ln of s, because we need to do brute force to generate all subsequences. And while generating subsequences itself, you can see whether it equals to t, and you can increment the count. Now what will be the space complexity? Are you using any extra space to store the subsequences? No, we don't need. Then directly when we get the subsequence, we compare it with t. If it is equals to t, we increment the count. Now with this exponential complexity, do you think our problem will get executed? If you look, length of s can be up to 1000. If you do exponential of 1000, it is a too big number, so you can't solve it in a exponential way. You need to come up with any other optimal way to solve this. What is the optimal way to solve this instead of you doing backtracking? Let me check if there is any repetitive pattern in the backtracking. First you take r, then you can take a or skip a, take or skip, and then you b, take or skip. This is how you do backtracking, right? Similarly, r also take or skip. Now if you look, if you are not taking r and you are taking a, you are taking b, you are taking b, you are taking b, you are taking a, you are taking t, right? Let me check. RABBID. You take R, you skip A, come to B, skip B, take B, IT. Now how do you find out number of ways we can take a subsequences? Suppose there are X R's in the S. Now till which R you can take to ensure that subsequence will contain all the characters of T? We need to take last R such that all the remaining characters to write also satisfies the remaining word in target. Which is what is the remaining word in target? ABBIT. So now we just have only one R. We take this R and we need to check whether the right satisfies the rest of it. Right? Now if you take a look at this, ABBIT should satisfy ABBB. I got confused. ABBIT should satisfy ABBIT. Yeah. Now we only have one A, so A will be skipped. Now BBBIT should satisfy BBIT. Now we are having 3 B's. Out of 3 B's, we need 2 B's. So for R we have only one way. For A we have only one way. Now for B's we have 2 ways, because we can select 2 out of 3, which is combinations 3C2, which is 2. And to take I we have one way, to take T we have one way. Now sorry, it is not ordered. So 3C2 in the sense 3 factorial by 2 factorial into 3 minus 2 1 factorial, it is 3. So if you look at here, you multiply all these things, 1 into 1 into 3 into 1 into 1, which is equals to 3. We got the answer. Now let me solve the same for the second one. If you take T, we have BAG. Now first character in the target is B. How many times B is there in S? It is 3 times. What is the rightmost value of B which satisfies AG towards right? It is third value. If you take first B, we have AG towards right. If you take second B, we have AG towards right. If you take third B, we have AG towards right. So how many B values satisfies this? 3 B values satisfies this. Right. Okay. Now we check A. How many A values satisfies having G as the right? We take first A, there is G towards right. We take second A, there is G towards right. 2A value satisfies. How many G values are there such that B and A are towards the left? If you take this G, yeah, B and A are towards the left. If you take this G, yeah, B and A are towards the left. So you can take both B's. Now what are the number of unique subsequences they are asking? This is the tricky part. Now we find the subsequence. Now we need to find unique subsequences. Back. Can take any B, right? Last AG and any B. First BA and last G. First BA and this G. This PA satisfies 2 G's towards left. Think it as this way. You take first B. Number of ways you can get AG towards the right, which are 3 ways. If you take B towards third character, number of ways you get AG, 1 way. If you take B towards the fifth character, number of ways, 1 way. This is simple terms instead of going in a complex way. Now take this as a recursive way. First you check B. After B you need to consider AG towards right. Then you will consider A. How many times G is repeated towards right. So I'm just thinking, how can we write it in terms of algorithm? We are having we are checking first character, and then we need to check the next second character, and then we need to check the third character. It is still coming back to recursion. Is there any repetitive pattern in that recursion? So what we are doing in recursion, every character in S, I have two choices. I can take at that index or skip. So now I recursively go, let I will be the index in S and T, J will be the index in T, and I will be recursing till I equals to J, and if I could reach J equals to M, then I can form entire target. So we just return 1. It would take complex exponential 2 power n complexity. Now if you look, there is a repetitive pattern. So once we get I aligned, this I can be aligned multiple times. For example, if I take B here once, now I don't need to take this B again. I just need to focus on rest of the A comma G. So I will memorize at this I and J. If it is meeting, then my only concern is to look towards the right. I'll memorize at this I comma J, so that whenever I come again, I just return that, hey, I have already gone through this I comma J. I just need to check all the characters towards the right, which are A comma G. So if we memorize it, the time we are traversing through all the length of S, which is N, and all the length of T, suppose M. So by traversing all the length of T for every S character, we are getting the count of number of subsequences. But here we are memorizing. For I comma J, we are checking whether we have already stored it or not. So space will also be O of n cos M. Now, as we know, like it is a standard DP way. If we are doing memorization, we depend on the next row. So we can do bottom up instead of doing top down. There is nothing much difference. It's just we are avoiding that stack space of doing recursive calls by taking a vector, 2D vector, and the logic remains same. We convert the base logic, like once we reach I equals to 0 and J equals to 0 from when we traversing from the end of S and T, we get the right number of subsequences. Till here we are fine. Is there any way to optimize this further? We depend on I comma J. Once we have I, we check towards the right, and first let us write the code for bottom up, and let's see if we get optimize it. So let me take n as s dot size and m as t dot size. Now I need a DP vector. Since they said that 32-bit signed integer, I need to take unsigned long. Da. 2D DP we need. DP of n plus 1 comma vector of plus 1 comma 0. The reason we are taking n plus 1 and m plus 1 is we need an extra free state to calculate from the base case. If we only take till n and m, we don't have space to take base condition. Got it? Now we traverse through all the characters of S less than n I plus plus. Now for every character in S, initially, like if we don't check any letter in T, what would be the case? So empty subsequence is one case, so I will assign it 1. So here I am taking empty subsequence of S. This is the base condition I am going with. Now I'll traverse from the end of S and I will traverse till it is 0, I minus minus. The reason I am traversing from the end is I am trying to do bottom up. For int j equals to n minus 1, j greater than or equals to 0, j minus minus. Yeah, for every S I am traversing every T. And now if we skip the current character, what is the chance? Suppose I skip this S, which is T. Number of ways to achieve it would be which are towards the right. If I skip it, it's just I'm just having possible ways towards the right itself. I'm not adding any possible ways. Here it will be 0. Yeah. Now if at all I take, when will I take? If both characters are equal, if S of I equals to S of T of J. Now both are equal, I'll take this. Now if I take this, what will be the condition? If I skip this, it would be if I skip, I don't need to consider anything from I. If I not choose to decide, if I not choose S of I, then I simply move towards next character in S and T stays where it is. So I'm just incrementing I plus 1 and just staying there. Now if I take it, then I can increment both I and j. So dv of I comma j, sorry, we are coming in a reversed order, so I will become minus 1, j will become minus 1. So now here we also need to consider the rightmost, because whatever towards the right are there already satisfies S equals to T. dp of I comma j, I should add on dp of I plus 1 comma j plus 1. Now I think this works. If I skip, I just need to check number of ways when I just skip s and keep t as it is. If I take, then both I and j will move one pointer towards left, so we consider and add number of ways till we can reach I plus 1 and j plus 1, right? Now this is ways after skipping, after taking, fine. We just need to return dp of 0 comma 0 because we reach 0th element in both the cases. Let me run and check. Oh wait, it is do db. La 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 la. It passed. Let me submit. Yeah, it works. So we are basically avoiding the repetitive pattern when we take or skip any element, and in this repetitive pattern we have this way. Either we can skip s where t stays at the same position, or if we want to consider when both are equal, then we need to add the possible ways towards the right and one new way. In this way, in this way we get the total number of subsequences which are unique. Let me think, is there any optimal way? If you take a look here, we are only depending upon the next row. That is, as we discussed in the example, once we are aligned that b is equal, the only thing we need to care about is a, which a satisfies our condition. Same, when we go towards a, we need to focus only on which b satisfies which g satisfies our condition. So let me optimize it further. Instead of 2d dp, I'll take a single dp. Vector long. Yeah, I got a single dp of length m plus 1 because we need to take care of t. Now we have a dp of single dp, so we don't need to assign for every I, we just need to assign for current. Now for I equals 10 minus 1. Do we need to assign dp of I comma j to I plus 1 comma j? Since we are having singular dp, it will always be having the value of I plus 1 comma j, so we can remove this. Now we are not having any I, dp of j will become plus equals to dp of j plus 1, right? Is this right? Let me think. dp of I plus 1 plus j plus 1, dp of I plus 1 comma j plus 1 will be equals to dp of I comma j plus 1, since we took from the previous row, and we are dp of I comma j plus 1 means dp of j plus 1, right? Yeah, this works. At the end we just return dp of 0. Let me submit and check if it is working. It is dp. What is t issue? J plus 1, dp of m is 1. Just returning dp of 0. Why it is coming as 6? dp of why it is coming as 6? For G we have 1, for A wait, if we are getting from dp of I plus 1 comma j plus 1, why it is causing issue here? Where is the issue? S of I and t, dp of I comma j needs the tracking thing which is already took from the previous array. What is this issue? We are going from n minus 1. Oh, wait. Why am I? If I already update dp of j plus 1, how can I get the previous dp value? I should traverse in the opposite way. for I equals to 0, I less than n. I plus this. Now for the 0 I need to assign it 1. Now for the next element I need to take the current. Then I can preserve the dp of j plus 1. Yeah. Now I just need to return last element dp of m. Let me check if this works. Yeah, let me submit. Yeah, the issue was when we are traversing from the right to left, we will be already modifying dp of j plus 1. So if we again add that newly added dp of j plus 1 to dp of j, the result will be corrupted. So first, either we need to store the next dp value in a variable called temporary and then add it, or you need to traverse from left to right so that the dp of j plus 1 is preserved. I hope you got the solution. Yeah, and for the optimized one, time complexity remains the same. We need to traverse all the elements in S and T. For every S we need to traverse all the characters in T. Here space is O of M. Since we should only consider the characters in T, we don't need to worry about characters in S. Yeah, this is what it is. Let me know like what is the next question that I can solve. This is pretty solid actually. I got a bit confused when we are looking at the take case. This is good. Let's go.